All right. So all my stuff was still in the building. So I rewrote out some of the problems here, and then I will show you some of the others in StatCrunch. I'm not going to work out the entirety of every problem, but I will explain enough that you should be able to then carry out any calculations or questions, the rest of it yourself. So first one that was asked was section 3.1, number 22. So what hold on, sorry, I gotta move this down because somehow it's gotten off of my pencil. Okay. All right, so I wrote out the data a little bit differently than the way it's displayed in the book. The book, it's more compact, but I just wrote out all 9 names of the students and their travel times that were associated with them. So part A asked you to determine the population mean. So it did tell you in the directions for number 22 to treat these 9 values as a population. So the way we determine mean is to add them all up and then divide by the total. So sum of all x, so these are our x's. So I just took 39 plus 45 plus 21 all the way on down the line, should give you 238. There are 9 total people there, so that is our capital N. Remember that for means, medians, mid-range, standard deviation, all of those things, unless they tell you otherwise, you should round 1 decimal place past the original data. So 26.4, it should be rounded to the 10th place. And the symbol we would use is mu because it's a population. Part B asks you to find 3 simple random samples of size 4 and determine the sample mean travel time of each of those samples. So I only showed this once because you should be able to do it the other times, and then base your answers to part C on your part B. So I don't care how you find your simple random samples. This is a small number of a population to choose from. So I just used my calculator, which I had taught you how to do the random integer. So from 1 to 9 and choosing 4 of them because it says size 4. So the way I had listed them, I made Amanda assigned number 1, Scott number 2, Amber number 3, so on and so forth. And so when I did this random integer in my calculator, the first time it popped out this. So that means person 7, person 3, person 1, and person 9 were selected for my first simple random sample of size 4, which were these 4 people. So I took those 4 people's numbers, I added them up, I divided by 4. This gave me my sample mean for my first of the 3 simple random samples. Notice that I used X bar and not mu because that's the symbol that we use for samples. So you need to do this twice more. So I don't care if you use StatCrunch or the table or if you use the calculator, but you need to have 2 more samples of size 4 and show your means for each of those. Part C then asks which samples result in a sample mean that overestimates the population mean, which underestimate, and do any samples have the sample mean equal to the population mean? So you're just comparing your answers, which may not be the same as mine, may not be the same as somebody else's, but you're comparing them to the 26.4. So again, I only showed you one of the 3 samples here, but in mine, this is an overestimation of the population mean because it's bigger. So you can answer based on that. All right, next questions were 6 and 8, which this is just like what we did together in class. And I had also sent out a video where I finished one additional example. So if you haven't watched that, I would suggest that you do so. I am not going to do both 6 and 8 because really they're the same thing. And I'm not going to give you all the work. You need to have practiced it at least once. So I did part of number 6 here, most of number 6, and I'm going to leave number 8. I did write out which formula you should be using from the notes, and that's because this is population. Now, remember there are two different formulas for both sample mean and for population mean. I prefer these ones. These are known as the computational formulas. I prefer these ones because they're easier to use. The other formulas, they're maybe a little bit easier to understand why they work, but they are much more difficult to actually come up with the values. So we want something that's going to be easy to come up with the values. These are the easier computational formulas. So I also made a note here so I wouldn't forget. If you're still having trouble with this, read the book. These examples, there's always examples of things in the actual text, and these ones are on page 133 to 135. So you have to understand what the notation is saying. This first part under the square root says the sum of all xi squared. Xi just means individual data value. So this would be xi1, this would be xi2, xi3, xi4, xi5. So when it says the sum of all xi squareds, that means you have to square each individual data value and then add them all up. That is different from what I see over here, for instance. That guy says the sum of all xi first, because it's in parentheses, and then squaring that value. The n and the n minus 1 are the easy part. Those, of course, are just the number of values in the sample that we would plug in for n. So I wrote out all the work here. The sum of all the xi's just means add up all the original data values. So I showed that. I showed what I got. In order to find the sum of all xi squareds, I first have to know what the xi squareds are. So I took 83 and I squared it. That's right here. 65 squared here. 91 squared, so on and so forth, on down the line. So these are all my xi squareds. When I add all of those together, it gives me this guy. And so then I now have everything I need to plug into the formula. Sum of all xi squared, right here. The sum of all xi squared over n. 1, 2, 3, 4, 5 pieces of data. N is 5, and then the denominator, 5 minus 1 is 4. So once you have it to this part, you should be able to finish it. Obviously, use your calculator. Again, make sure that when we're rounding one decimal place past what the original data is. And then, like I said, I'm not going to do number 8 as well. You can read in the text if you want. But it's virtually the same type of formula, except that we're using capital N to mean the members of the population. All right, the next couple are in StatCrunch, so I am going to first attempt to get to the actual data of the text and then to the StatCrunch itself. So number 28, here it is. So it says you've received a year-end bonus of $5,000. You decide to invest the money in the stock market, have narrowed your investment options down to 2 different mutual funds. These are the historical quarterly rates of return for each mutual fund over the past 20 years. Describe each data set. That is, determine the shape, center, and spread. Which mutual fund would you invest in, and why. So if we're deciding what to invest in, we should find the shape, center, and spread for each data value. So if I then go to my StatCrunch, where again, I've provided within Canvas for you the direct links to all the data. Here is the data for the mutual fund A and mutual fund B. I'm only going to do mutual fund A for you. You need to do the same for mutual fund B, and then you can compare them to answer the last part of the question. So if I go to summary stats, and choose columns, I'm just going to do mutual fund A for right now. And I can choose whichever of the values I want to find. It did say shape, center, and spread. So I'm going to choose, I always forget which one I have to press. I thought it was control, but maybe it is not. All right, so I'm going to do mean, standard deviation. Nope. The hair, I got it. I must just not have been holding it down. I'm going to have it do n just because n should equal 20. The mean, the standard deviation, and I'm also going to have it do the median because remember that depending on what type of data we have, that could affect what kind of measure we want to use to determine our values, because we typically use mean and standard deviation for symmetric values, and we typically use median and IQR for data that is skewed. So I've got all of it here so that once I see the shape, I can decide. You could determine the shape first and then only pick some of these if you want. So once I have that, here are the values. So for center, you would just say that the mean is 3.05 and so is the median. Then for spread, you would say that the standard deviation is 2.99, because since these are to the tenths place, you would go hundredths place, and that the IQR is 4.15. So then I would look to go to graph and histogram for mutual fund. And let's see. I'm going to let it bin itself for right now so that I don't have to look at the data if I don't have to. But if they like look weird, then I might change it. So go to compute, and here I can see a histogram. So it looks like that perhaps they've done, I don't know, like 2-ish maybe for each bin, and they seem pretty close. Like, look at this one. This is the only one that's slightly higher. This data is very symmetric. It's almost perfectly symmetric if this third bar were at 3 instead of 4. So this is very symmetric data for the shape, we would say. So because of that, mean and standard deviation are fine. So those would probably be our lists for the center and the spread. So then you would do the exact same thing for the other column. So mutual fund B, choose it, do a histogram, determine the shape. Then you can do summary stats for that column to list the center and the spread. Then, based on that data, you choose which mutual fund you want to invest in and why. So the key is backing your answer up with statistical evidence. So that's what's important. That's what shows whether you really understand it or not. All right, next I am headed, I believe, to 48, maybe. Yes. Okay, so 48 says the data set on the left, but here it's kind of underneath, so it's the top, represents the annual rate of return in percent of 8 randomly sampled bond mutual funds. Data on the right, underneath, represents annual rate of return in percent of 8 randomly sampled stock mutual funds. So we have bond mutual funds, stock mutual funds. Part A, determine the mean and standard deviation of each data set. So if I go and use my links, I have for me here all of that data. One for the bonds, one for the stocks. So again, it asks you to do both in this case. It's asking you to find the mean and standard deviation for each of those. So stat, summary stats, columns. Again, doesn't matter which one you start with. Let's say I start with bonds, but I'm going to do mean, and then you press Command or Control. I'm not sure which one it is on a Chromebook, and highlight both mean and standard deviation. You could do them separately if you can't get them to both highlight, but then I click compute and it gives me the values. Remember, you have to round them appropriately. This in the bonds is rounded to the 10th place. So my answer should have 2 decimal places for both the mean and the standard deviation. So I'm rounding these answers here. So I'm not going to do the other part of part A. You need to do the same thing for the stock mutual fund. Then for part B, based only on the standard deviation, which data has more spread? So you answer part B based on whichever one is bigger, because a larger standard deviation means that the data is more spread out. So you're basing it only on those standard deviations. Then, what proportion of the observations is within one standard deviation of the mean for each data set? So again, this is for each. You have to do this twice. I'm going to walk through how to do it for the first one, and then you'll need to do the other. So within one standard deviation of the mean. So for the bonds, the mean is 2.38, and my standard deviation is 0.67 approximately. So when I look at the numbers, I'm going to take the mean, 2.38, and I'm going to subtract a standard deviation, so minus 0.67. That gives me 1.71. Then I do the same thing, but I go above the standard deviation. So I had 1.71 for the below the standard deviation. Then I go above, and that gives me 3.05. So 3.05 and the 1.71. So let me go back here and scroll down here. So 1.71 and 3.05 are the values that are within one standard deviation for the bonds. So I look at my actual data and I'm deciding what proportion actually fall in there. So when I look at the bonds data, I'm asking within one standard deviation of the mean. So between 1.71, and 3.05. So this first one it's between that range. This is too big, this is too small. This is within the range. 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 This is too big. So I had 1, 2, 3, 4, 5 of the data spots that were within 1 standard deviation of the mean. So that means that 5 out of the 8 would be the proportion that fall within 1 standard deviation of the mean. Now you can list this in decimal form as well. It doesn't have to be a fraction. All right, so then if I go back again to scroll, sorry, I gotta be able to get to the scroller here. Part D, the coefficient of variation is defined as the ratio of the standard deviation to the mean of the data set. So CV equals standard deviation divided by the mean. So when we looked here, standard deviation was 0.67, the mean was 2.38. So we would say that for this data set, we have 0.67 divided by 2.38, and this would give us that particular value. Now again, you have to do this for the other data set as well. So for the stocks, this was for the bonds. So all of this that I wrote out was for bonds, but this gives me 0.28151, so on and so forth. And so when I do standard deviation divided by mean, that gives me that value. It tells you here that it's unitless and allows for comparison in spread between two data sets by describing the amount of spread per unit mean. Because then otherwise, if we're measuring in different units, when you have larger numbers, it's going to have a larger standard deviation because the numbers are bigger to begin with. So we already computed the coefficient of variation for the bonds. You need to do so for the stocks and then re-answer the question that you answered in part B. Which data set do you believe has more spread according now to these coefficients of variation? Part E, it has a new set of data, so you have to actually go in and load that new set of data in. So you can see it says 48E. I will say on this one that in the links, it didn't have the ending on it. So like I had to type in, they normally, when you go to data and go to upload and then from the web, all of those links should end in .csv, and this one forgot the .csv. So that, I copied them directly from the website. That's an error on the website's part, but it's a pretty easy fix, and when you fix it, it does upload the data correctly. So this is the data that you need. You could always just look at mine and hand type it in if you wanted to. But then it asks you for each of those data sets, find the mean and standard deviation. So go to those summary stats again. And then would you say that the height of males is more dispersed based on the standard deviation height measured in centimeters? So basically, would you answer that there's more spread based on what you see in centimeters and why? Then it wants you to calculate that coefficient of variation again for each data set. So again, the formula's up here. You do standard deviation divided by the mean to get that value. And then it says, once you've done that, what does that tell you? Basically, is what it wants to know. All right. The last one that I'm going to go to here, there we go, was number 8 from section 3.4. So it said the average 20 to 29-year-old man is 69.6 inches tall with a standard deviation of 3 inches, while the average 20 to 29-year-old woman is 64.1 inches tall with a standard deviation of 3.8 inches. Who is relatively taller, a 67-inch man or a 62-inch woman? So this is asking you to compare them to their own averages. The way that we do that is with Z-scores. So the formula is in your notes. X minus mu divided by sigma. So data value minus the mean divided by the standard deviation. So I did those Z-scores twice, once for the man with the man's data value, the man's mean, the man's standard deviation, and then the same for the woman. So remember, when they're asking who is relatively taller, this is the required work. You can't answer this question correctly without the work. But remember that the meaning of a Z-score is how many standard deviations above or below the mean that data value is. Both of these are negative because they're both below the mean. So more below the mean, in this case, means shorter. So the man's value is more negative. It's further away from that mean. So who's relatively taller? The 62-inch woman, because the 62-inch woman is closer to the mean than the 67-inch man. A general question that I was asked to answer was, what does it mean when it says to interpret the data? It means to tell what that data is telling you about the real life situation. So often there's more than one correct way to interpret the data, but it wants to know what it means. What's the real life meaning of what you found from that data or from those statistics? All right, hopefully that helps you out. Make sure you've got everything finished and corrected, ready to hand in at the beginning of class when I see you next.